Good day, students. Welcome to click on graphing parent sine and cosine functions part 2. So right now the title for the lesson, graphing parent sine and cosine functions. This is part 2. Okay, ready? Alright, so let's write down the learning objective for this lesson. Learning objective. Alright, so this is a learning objective. Write this down. By completing 3 appointment problems, appointment set of problems, you will apply graphing techniques in graphing parent, sine, and cosine functions on specified domains. Okay. So when you're doing the appointment problems, you're going to have each problem set has 3, so they're going to be a total of 9 problems. So you're going to do 3 sets of 3. Okay. All right. So let's consider the following example. Let's write down the instructions first. So the instructions are as follows. Graph each function. Say examples. So instructions is graph each function for the given interval or on the given interval. On the given interval, state the interval where the function is increasing, decreasing. I'm going to state the max and the minimum value. Okay, so that's a task. So number 1, let's do y equals sine x on the interval negative pi, I don't like my pi, let me get a new one. Negative pi to 3 pi over 2. Okay? So let's see how that looks like. Let's make a graph, okay? So since this is a parent function, we are just going to partition our x coordinate by breaking 2 pi into 4. Okay, so if we break 2 pi into 4, it's going to give us pi over 2. So this is going to be our calibration for the x coordinates. Alright, so let's put it so in the center, and there goes your x axis. I'm going to go 1, 2, 3, 4 for my max. From the center, 1, 2, 3, 4 for my min. This is negative 1 and 1 because there's an imaginary 1 here. And then for the calibration, um, every two tick marks, let me call that pi over 2. So two tick marks to the right is pi over 2, or pi over 2, and then this is pi, and then this right here is 3 pi over 2. And then I stop there because that's how far I'm going to the right. Going back, I'm going to back up negative pi over 2, and then back up another two tick marks, negative pi. That's good enough. Okay? So there's my, there goes my calibration for my x and my y-axis. This is exactly the same as what we've been doing before. Let's put in our max and min boundaries. Okay, this is how high it goes. It goes as high as there, and it goes as low as there. Alright, so we're graphing the sine. Remember, the sine function starts from 0. So sine starts from 0 and cosine starts from 1. Okay? So for cosine, CC for sine, CC for cosine. Cosine starts from 1, sine starts from 0, okay? So let's graph the sine. Remember, your sine are like S's and your cosine are like cups, okay? So starting from the center, sine starts from the center, and then you're going to go center max, and then center min. Alright, and then going back, you're going to go center, from the center to the mean, and then from the mean back to the center. Alright, so since we're ending up with a parenthesis here, this is going to be an open circle. So this will be an open circle. Open circle, this is open, and this one right here is closed. Okay? So that's what it's going to look like. Alright, let's connect the dots. So starting from here, we're going to go straight out of the center, and then curve towards the bottom, and then curve out the bottom. Straight, that doesn't look good. Start it again. Curve out the bottom, curve out the bottom. Straight through the center, straight out the center, curve at the max, curve out the max, straight through the center. And then you go straight out the center, and then you curve right at the mid, right there. Okay? So there goes your graph. Alright, now let's take the intervals where it's increasing, decreasing, and all that cool stuff. So you can clearly see that from here to here, it's decreasing, and then from here all the way to there, it's increasing. The ant is walking up, and then from here all the way down to there, it's decreasing. All right. So let's write it in interval notation. Increasing is increasing from negative pi over 2 all the way to pi over 2. Okay? That's where it's decreasing. So, like that. And then that's where it's increasing. And then it's decreasing from uh, negative pi all the way to negative pi over 2 union, stick it with pi over 2 all the way to 3 pi over 2. Alright? So there you have it. Remember, you have a parenthesis here because at negative pi over 2 you're neither increasing or decreasing, and then over here you're neither increasing or decreasing, so you have a parenthesis there. You have a closed bracket here because at this point you're actually going down. Okay? There goes your graph. So you have a max. Your maximum is this right here, y equals 1. There goes your max. And then this is not a mean because it's open, but hey, this is a mean right here. So your minimum is negative 1. Minimum is y equals negative 1. Alright? So that's all I need for today. Let's take a look at another example. Example number 2. What if I have y equals cosine x on the interval negative pi over 2 as less than x as less than or equal to 2 pi? Okay, what if I have that? Alright, so we're going to do the same one for this problem, y equals cosine x. So we're going to break it by pi over 2's here again, because it's a parent function. More to the positive side, because we're going all the way to 2 pi. Alright, so this is my y-axis, this is my x-axis. I'm going to use 3 points this time so I can have a better spread. So 1, 2, 1, 2, 3, call that pi over 2, and then go back 1, 2, 3, negative pi over 2. The center is 0. So pi over 2, pi, 3 pi over 2, and then 2 pi. Alright? And then we're going to go 1, 2, 3, 4. That's my max. 1. 1, 2, 3, 4. That's my mean. Negative 1. Alright, let's put in our boundary points. The highest point, or the maximum for this function is 1, because it's a parent function. And then the minimum is negative 1, because it's a parent function. The parent sine and cosine functions have the same amplitude. Alright, so let's put in the points. So remember, sine starts from 0, so cosine starts from 1, right? CC. So let's start from, we're going to start from 1. Okay, so you start from 1. There's no line here, so when we get to pi over 2, it's going to be an open circle. There's a line here, so when we get to 2 pi, it's going to be a closed circle. So that there, this one is going to be open. So you go down to the right, and then you're going to go down to the, you go down to the left and down to the right. Alright, so you have max, center, mean, center, max. So you have a cup, and then the other piece. Alright, so let's connect the dots. So you curve out the max like this through the min, and you curve out the center. Straight out the center, curve out the min, curve out the min, straight to the center, straight out the center, and then curve out the max. Oh, missed that last piece right there. Straight out the center, and then curve out the max, okay? And then curve off the max, straight through the min. There goes your cosine curve. Okay? Alright, where is it increasing, decreasing, and all that other cool stuff? If I can get this correct. Alright, so it's increasing here, and increasing here, and it's decreasing there, right? So let me just replicate it, indicate it for you all with an interval. You see from um, here to here, it's increasing, and then from here all the way to there, it's increasing also. Okay, you'll see that. So here it's increasing here because the ant is walking up, 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 and then here is also increasing because the ant is walking up, 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 up. All right, and then in between here, from here to here, this middle part right here is decreasing. Right? You see that? It's decreasing because you have your ant facing where? Your ant is walking down, it's facing down, decreasing all the way down. Okay? Alright, so let's state them. Increasing. It's increasing from, since this is an open circle point, you can't include it, negative pi over 2, all the way to 0. 0 is a max, so it's neither increasing nor decreasing. Union pi, it's an extrema, an extreme point. It's neither increasing nor decreasing. So pi all the way to 2 pi. That's also an extrema, so it's neither increasing nor decreasing. Right? So for decreasing, we're just simply going to go from 0 all the way down to pi. Okay? Your maximum. Your maximum is going to be 1. You have two maximums there. They coincide with each other. And your minimum is going to be -1. Okay? So there you have it. Alright, now we're going to get started with the appointments, and then I'll come back and do some more advanced problems. Alright, welcome back. Now, we're going to try an example. This one is going to be graphing. Graphing slightly transformed trig functions. Slightly transformed. Okay, graphing slightly transformed trig functions. Okay, we're going to go all out next class, but today we're going to just make a slight transformation, okay? We're just going to alter the amplitude of the graph. But next class we're going to go all the way in the sense that we will alter everything, the amplitude, the period, the phase shift, and vertical shift, okay? So number 3, we're going to do the same thing. We're going to consider y equals -2 sine x on 5/2, close bracket, all the way to 0. Okay? So since this is a stretched parent, because of this -2 is kind of stretching it, we're still gonna, it doesn't affect the vertical side, it just affects the horizontal no, it doesn't affect the horizontal side, it just affects the vertical side. Okay, so we're still gonna go with 2 pi, break that into 4, we're still gonna go by pi/2, okay? So let's make a coordinate system. Oh wait, the problem is wrong, it's supposed to be a minus. Okay, it's supposed to be a minus. So, making our coordinate system, it's going to be very negative, so we want to make the left side as long as possible. Alright, we're calibrating by pi/2s. So we're going to go 1, 1, 2, 3, 2, 1, 2, 3, 3, 1, 2, 3, 4. What is 5 pi/2? 5 pi over 2 in mixed numbers is 2.5, right? So we're going to go 2 pi and then a half. So this is pi/2, negative, -pi, -3 pi over 2, -2 pi, and guess what the next one is? Boom. -5 pi over 2, because it's the same as 2.5, right? So it's -5 pi over 2. Okay? And this is 0. Max and min, 1, 2, 3, 4, max. Ooh, wait. Max is not 1. We have a number there, 2. So this number basically stretches our max. So this, instead of it being 1, it's not going to be 2. 1, 2, 3, 4, min is going to be -2 because of this factor. This factor stretches the graph vertically. Okay? So we put our max and then our min. And now we're going to plot the dots. Now you know sine starts from 0 and makes the S sign. So I'm going to start from 0. Okay? And I'm supposed to go down here and up there, right? But wait a minute, you have a minus. What does that minus do? It switches the whole order. So instead of it going up, down, you're going to do the reverse. Instead of going up to the right, you're going to go up to the left. Center, min, center, max. Okay? Starting point is an open circle, so I could alter that and make that an open circle. Okay, so you see the regular sine curve that goes like this has been switched around. Okay, it has been reflected vertically. Alright, so now let's connect the dots. So you're gonna go curve out the max, straight, doesn't look it. Curve out the max, straight towards the center, straight out the center, curve out the min, curve out the min, straight towards the center, straight out the center. I can't stand this. Okay, like that. Curve out the min, straight towards the center, straight out the center, curve out the max, curve out the max, straight towards the center. There goes your curve, okay? So where is it increasing? I can see that from here all the way to there. It's decreasing. The ant is walking down. And the ant is also walking down from here all the way to here. So your ant is decreasing here and here, then we can easily conclude that over here it's increasing. Right? So let's write it. Increasing. It's increasing on negative 3 pi over 2 all the way to negative pi over 2. And it's decreasing on a combined or stitched interval. So it's decreasing from negative 5 pi over 2 all the way to negative 3 pi over 2. Union, I'm going to unite that with the other piece, which is from negative pi over 2 all the way down to 0. Since 0 is an open circle, even though it's decreasing as you approach there, you never really get there, so you cannot include 0. There you have it. Okay? Alright. So your max is going to be what? Your maximum value is going to be y equals 2. That's the highest point because it has been stretched. And your minimum is going to be y equals negative 2. Okay? So there you have it. I'm going to give you some board work problems to try, some slightly more complicated ones, and that'll be that, right?